2, the first one, which I'm going to use the red ink for, is ready to graph. Yeah? It's already in y equals mx plus b. It has y by itself right here. Equals m, which is 1 over 1, x plus b, which is negative 5. So we know it crosses at negative 1, 2, 3, 4, 5 right here. So let me put this dot right there. And from that point, the slope is up 1 over 1. So if you do go up 1 over 1, you only get to right there, which is super tiny to leave your line like that. So I recommend to keep going with the pattern of up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, all the way through as long as you want. And you could even go backwards with that pattern to make it go that way. Then you could draw your line afterwards. Hopefully you could draw better than me. Put some arrows on it also. And the bottom one, it's not ready to graph yet, so let's get it in slope-intercept form. I want to get the y by itself. I'm going to add 2x to get rid of the minus 2x, add 2x. So we will have, let me rewrite it over here on the side. We're going to have 2y equals 2x minus 10. Now we're going to have to divide everything by 2. Divided by 2, divided by 2, divided by 2. We will have y equals 1 over 1x, or just x, minus 5. And if we think about this, let's graph this one in blue. It's the same equation, we just made it look different. And when you realize that you go to the y-intercept of negative 5 in blue and you put that right there, it's the same exact graph. This equation is the same exact equation as the one above. So if you were to graph it in blue, and you go up 1 over 1, up 1 over 1, what happens is that you end up with the same exact line. So these lines are perfectly on top of each other. And remember, the whole purpose of graphing, since one line represents the infinite solutions of one equation, and the other line represents the infinite solutions of the other equation, what you're trying to find is that single point that they share. So looking at the red line and the blue line, which point do they share? All of them. How many is that? Is that 10? Is that 15? Is it 30? Infinite. So this answer is infinitely many solutions. I'm just going to write IMS because I'm feeling lazy today. Anyway, if you look at the back of your worksheet, you'll see it graphed for you and the answer right there for you. Let's take a look at these systems. We learned 2 methods yesterday: substitution and linear combinations. And to tell you the truth, I probably wouldn't use substitution on any of these. I'm looking through them. You know what? I would have used substitution on this one, number 2, instead of graphing. I could have, since I already have y by itself, y equals x minus 5, I could have taken that x minus 5 and plugged it in right here into the y. And then I would have had a single variable equation I could have solved. So, but I'm not going to do that. Down here, there is no variable, it's all by itself. So it might be a good idea to just use the elimination method on all of them. Is there anyone you would like to see? Let's check out number 6. Ladies and gentlemen, we are using the elimination method. We want either the x's to eliminate or the y's to eliminate. And we're going to do that by combining the lines. So the question is, if I combine x with 2x, what do I get? Does it cancel out? No, I get 3x. If I combine negative 3y with positive 3y, if I combine the lines, that gives me negative 2y. So nothing eliminates. So I'm not going to combine the lines yet. That's why they call it linear combinations method, because you combine the lines, and it's also called the elimination method because you want a variable to eliminate. So as we just saw, nothing eliminates, so I need to modify one or both equations. So which one do you want to cancel, x's or y's? It doesn't even matter. Pick one. X. Okay, so let's cancel out x's. Now we need to think, the only way that this term up here is going to cancel out with this term down here is if they're exact opposites, right? Exact opposites. So could I change this one to look like the opposite of negative 2? I mean, there I said it. Sorry. Could I change this one to look like the opposite of positive 2x? Yeah, by doing what? By multiplying by negative 2. Does that make sense? So I'm showing my work here. I'm putting the whole equation in parentheses. I put a negative 2 on the outside, and I want to distribute the negative 2 into each term. Now again, you guys told me I want x's to cancel. That's why I'm multiplying by negative 2, so that this could end up being a negative 2x, which will cancel with this positive 2x. So we're going to end up with a negative 2x. We're going to end up with a positive 6y. And we're going to end up with a positive 24. Now the bottom equation, we already have a 2x out in front. I don't have to modify it, so you just bring that down. In other words, rewrite this whole thing, rewrite it over here, right next to it, right below it. So I'm going to have a plus y equals 11. And now we are ready to combine the lines and eliminate. So let's combine these lines. Put a line like this. Negative 2x plus 2x cancels out. 6y plus 6y, 7y. Equal signs come down. 24 plus 11, 35. And ladies and gentlemen, as you see right there, we have a simple, nice one-step equation in blue. All we're going to do is divide by 7. And yes, y equals 5. You see, it's easy. Now we take that answer and do what with it?
Plug it in.
Plug it into which one? Any one you want. Right? You can do the top, you can do the bottom. Yeah, certain cases, certain paths are shorter or faster. But, I mean, both equations look easy. I'm going to go for the bottom one just because it looks like it has smaller numbers. So I'm going to rewrite the whole thing. This guy right here, I'm going to rewrite this whole thing. 2x plus y. But instead of y, I'm going to put parentheses. Equals 11. Now, why did I put parentheses? Because I know that y equals 5. And I'm going to take that 5 and put it right there. So once again, I'm going to take this 5 and put it right there. So I really have 2x plus 5 equals 11. I don't even need the parentheses, really. It's just 2x plus 5 equals 11. So let's solve. How do I get rid of that 5? So let me subtract 5 right here. It's getting messy, I'm sorry. Cancels out. What I do to one side, I do to the other side. So I will have a new equation that says 2x equals 11 take away 5 is 6. So my final answer, after I divide by 2 on both sides, x equals 3. Okay, so let me write that over here. X equals 3. So, ladies and gentlemen, you could write your answer as x equals 3, y equals 5, or you could go back and put your answer in coordinate format, x equals 3, y equals 5. Again, what does this mean visually? It means that if you were to graph the top equation, you would get a line. Graph the bottom equation, you would get a line. And both lines would share the point 3, 5. In other words, both lines would intersect at the coordinate 3, 5. Shugare? Okay, now let's say you were taking a test and you weren't too sure about your answer. You could always take your 3 and plug it into your x, take your 5, plug it into your y, and double check that it gives you negative 12 when you do the math over here. And then you would plug in 3 down here into this x and 5 down here into this y, and double check and make sure that it gives you 11. And if you've done that, check the top one, check the bottom, then you're absolutely positive you have the right answer, 3, 5. Not all of them are that easy. Some of them are ridiculous. Like, look at number 9. What do you do right there? You have to modify anything? No, you just combine, cancels, you get 2c equals 6. I'm not going to, that's too easy. I'm not going to do that. Okay. Number 14. Sure, why not? Let's see. Where's 14 at? Some of these are, I mean, what? Look at this. Number 11, all you do is combine the 3a with the negative 3a. That's too easy. These guys are set up for you. Number 14 is even easy also.
It doesn't come out to what it says in the back.
It doesn't?
No.
Is there any solutions in the back that are fractions? Those are fun.
5.
5? Hey, we should probably do number 5. Yes? No? All right, 5. So, we want to cancel out, we want a variable to eliminate x's or y's. Y's. Why do you pick y's? Because it's already ready to rock, right? All you got to do is combine the lines. So check it out. I don't need to modify anything. I don't need to modify the top equation. I don't need to modify the bottom. It's ready to go. This negative y up here is going to cancel with this positive y. Cancels. So what do I get as a new equation? I get 6x. The equal sign comes down. and I get negative 3. Yay? All right. I probably shouldn't have done all this mess up here. Let me just keep it clean. Let me just do one little line like that. Okay. Anyway, we have 6x equals negative 3. Let's solve that thing. How do I solve that thing? Divided by 6. X equals negative 1/2, ladies and gentlemen. 3 cannot be divided by 5. 6 could be, 5. Where did I get 5 from? 3 cannot be divided by 6. 6 could be divided by 3, but 3 cannot be divided by 6. So the only thing you could do with this fraction is reduce it, and that becomes negative 1/2. Okay, so we have an answer that is a fraction. X equals negative 1/2. Now, how could I find the other answer? Plug it in. I thought this was going to be more fun. It's pretty easy, actually. You could plug the 1/2 into any value you want. Into any equation you want. I want to go for the top one because I like the 2 instead of the 4. So my new equation, I want to write it over here to the side, is going to be 2x, 2, but what do I put in place of x? Negative 1/2. And then minus y, which, I don't know, equals negative 5. Now focusing in on the negative 1/2 times 2, that's easy because when you put it over 1, you could multiply top with the top, bottom with the bottom, or you could simply cancel out the 2's. 1 2's on top, 1 2's on the bottom. So I really end up with a negative 1 minus y equals negative 5. And of course we're going to add 1 here, add 1 over here, and you will get negative y equals negative 4, which means your final answer is going to be y equals 4. So we have our coordinate, our answer, our point of intersection, negative 1/2, comma, positive 4. So, any other questions? Did anybody want to squeeze in 14 before this video's up? Is that right? 14? Okay, so what would I do to cancel anything out? What's easier to cancel, C's or D's? If you choose D, you'd have to change this 2D to a 10D, and you'd have to change this negative 5D to a negative 10D. So you'd have to actually modify both equations. So it's easier to cancel out C's. I want to multiply this top one by what? To cancel out the C's? By positive 2. Because the bottom one's already negative 2, right? So if I get a positive 2C, it'll cancel out with the negative 2C. So let me write this to the side over here. I am going. So 2 times C gives us 2C, 2 times 2D gives us 4D, and 2 times negative 2 gives us negative 4. The bottom one's going to stay the same. There it is, written exactly the same. Now it's ready to combine and cancel. So the 2C and the negative 2C cancel out. The 4D minus 5D, it's going to give us a negative 1D, equals negative 4 plus 3 is negative 1, which means that D equals 1. So that's your D value. To find your C value, simply plug it in. I'm going to plug it into the top one. Let me rewrite the top one. So there it is. C plus 2D equals negative 2. C plus 2 blank spot equals negative 2. I'm going to take this one and plug it in right there. There's a 1 right there. So that's really going to be C plus 2 equals negative 2. And if you were to subtract 2 on both sides, you get your final answer that C equals, because it cancels there, negative 4. So your final coordinate, CD, you got to put it in alphabetical order. C comes first, D comes second. So negative 4, 1 would be your final answer right there to that one. Okay.